Good morning, good afternoon, and good evening, everyone. My name is Aniruddha Chasu. I'm the technical marketing engineer from HP Aruba networking team. Today's topic would be an AOS-CX 10.13 update on SNMP enhancements. Following would be the agenda. We would get into overview section of the topic, talk about certain use cases of the enhancements as well as the SNMP, get into the details, configuration, best practices. We'll have certain troubleshooting scenarios and the steps. We'll end the session with a demo. Getting into the overview section, let's talk about what is SNMP as the abbreviation goes, Simple Network Management Protocol. It's a very common protocol which has been around the industry for a long time, and I'm sure all of you are aware of it. We'll get into certain basics to build up the session and dive into the 10.13 enhancements. Now, SNMP is an internet standard protocol used for managing and monitoring the devices connected to a network by collecting, organizing, and modifying information about managed devices on IP networks, right? It's as you see on the diagram here, we would have in a very basic setup, we would have at least an SNMP manager. It would be running on a particular server. There's an NMS as well. They all will be providing the services of SNMP. It could be a monitoring tool, trap receivers, etc. Right? And we have a TCP IP connection to the managed devices. Right? Many of the cases, it's the networking devices like switches. It would also be an agent, right? Where we are talking about having MIPS and object identifiers. These are all the components of SNMP, and we have that in our next slide. So SNMP provisions the exchange of network and performance information between the network elements using the UDP port 161 and 162, right? But these two ports are very important for SNMP to work. The SNMP-driven network consists of a management system called NMS, an agent, and the managed devices. Can you see on the screen here? Yep. So what are the SNMP components? We majorly divide that into three, right? SNMP NMS, which is a network management system or manager or server, which is nothing but a centralized based, right? This one, a centralized based node system, which is used to monitor the network and also called a network management system. It interfaces the bidirectional flow of information between the NMS node and the network devices, right? So that's an NMS. Now, SNMP agent, right, collects management information about its local environment, stores and retrieves management information as defined in the MIP, which is predefined, which we have, signals an event to the NMS, right, over here, and can act as a proxy for non-SNMP manageable network devices. Now, managed devices are a part of the network that require some form of monitoring and management. For example, in our case, switches. Right? That's an SNMP agent. Now, what is an MIB then? MIB is Management Information Base. Now, SNMP agent maintains an information database describing managed devices parameters. We'll talk about a little more in detail about that and the enhancement which we have those parameters with. Now, NMS server uses this database to request the agent about those information, right? And that's how it works. The MIPS comprises of managed objects identified by the name object identifier, which we in general call OIDs. Further to our SNMP components, we have multiple versions of the protocol, such as version 1, version 2, and version 3 of them are supported. Availability of SNMP read operations such as get next, and get bulk. Availability of SNMP traps that can configure trap collectors through the CLI. availability of SNMP write operations such as set. These are all the components, and these are all you can use for various operations. Now, walk would be like SNMP walk can also be utilized. Now we are reading that SNMP write, we are setting a particular action through SNMP to the device. There are certain trap collectors, trap receivers, where we can send out the events of a particular managed device to a server and manage it remotely, understand it, monitor it using the trap component of the device. So what do we have in 10.13 as SNMP enhancements and its description? We have 7 enhancements. It's a big enhancement release for SNMP. What you see on the screen is what we have and their description, majorly on layer 3 addressing and physical entries. It talks about how we can have layer 3 IP addressing detail of the device and network to physical entries. We'll talk more about that in the detailed section, but that's what the enhancement does, talking about layer 3 IP addressing and IP to physical entries. We also have a firmware view stored in Flash enhancement. That means currently we can, in 10.13 onwards, have firmware view which is present, the images which are present in the Flash. We can view them and take further actions. We talk about it. We can also now have a set. We can look at what is the LED locator of the particular device. There are certain LED options, we can set them and through SNMP, and we can manage it that way to locate the devices in a particular site, in the data center, in the environment there, right? That is possible now. We have layer 3 routes SNMP enhancement, which talks about details of the layer 3 route present in the routing table. VSF member index, which has been very important as well. We'll talk more about it, what exactly it is, but as the name suggests, we are having a main entity of MIB talking about the VSF itself, and then we have VSF member indexing, which links that to the main entity, and that indexing has been improved and it has been correctly mapped to indicate that what member has the same indexing value, right? We'll look at it in the upcoming slides to understand more, but we have that improvement which helps a lot in monitoring tool scenarios. We have an enhancement on response source IPv6 interface, and that IPv6 specifically has been enhanced in this particular release. It can set IPv6 interface as the source of the responses packet of the SNMP. Now, finally, ending with the enhancement list, which we now support highly encrypted and highly authentication protocols used in SNMP version 3 user configuration. SHA 256 and AES 256 is now supported from this particular 10.13 release onward. Getting into the use cases now, there are tons of use cases of SNMP. Basically, if you talk about the parameters of the managed devices, we would want to have a way to manage a device, monitor the device of your network in a very simple and understandable view. So how do we look at, let's say, hundreds of devices on a network, and we want to have a view of it, we want to have a manageable capability, and we can use SNMP or leverage SNMP for that. Now, as you see on the screen, on a particular device, on a particular network, you may have various. I've just taken a few of them here. You have SNMP server GUI, which is a GUI base. It could be a a CLI based, a Linux, or an Ubuntu server, right? Which is connecting somewhere down the access layer switches, right? And that can be your SNMP server, and rest all the network elements you see could be which are SNMP capable, of course, can be SNMP agents and managed devices, right? Now, with respect to the enhancement, the use cases are tons, as we discussed in the overview section. We have layer 3 addressing, which managing the devices across campus and data center becomes crucial, right? Now, knowing layer 2 information with specified OIDs helps at various levels, right? We know those in IP interface details, we know ARP, a couple of ARP entries as well. Like we'll talk about it, and knowing those elements, knowing those important, crucial table entries will help manage the network and the devices. Similarly, having to know what images are present in your flash, like of the device, sites where WAN bandwidth may be less than ideal, and need to validate that the firmware successfully loaded before rebooting. A firmware upload could fail or just not complete when a wait timer expires, right? That's a possibility. Viewing software images beforehand will help. And that's the enhancement we have come up with. And we can now view the firmwares present in the flash before taking a call to do something about it. Next, we can also locate the devices in a particular data center or campus environment and set those LED in such a way to locate the device as well through SNMP. Managed devices located LED helps network operators on campus and DC environment for its location, right, troubleshooting, etc. So a lot of good reasons we have to need this managed through SNMP. Layer 3 routes. Similarly, we also need to know what routes are present in our device, the route entries in the routing table. Reading layer 3 routes on the managed device helps across network management, of course. VSF indexing, we'll talk about it. VSF member indexing improvements have been done. If you have, for example, just imagine that you have this topology is actually a network monitoring tool topology, right? Uh, you may have links here. Yes, you do. And right now you see the VSF having 3 members here. The link is connected, saying that this is a VSF system and it's taking that as one system, and the link is only one across to the other device. For example, that may be happening today, but with this improvement, you can have main entity indexing done with the member indexing as well. So the links of the member connecting to the other devices can also be now read through a tool, right? And that precision is now possible with this improvement. With respect to having a response source as IPv6, that's an additional benefit which we have on this particular enhancement. The source IP for SNMP response can remain fixed irrespective of topology change. That's one of the very big use cases. We can have the source IP for the responses fixed, whatever we want it to be manually, and irrespective of the topology changes, right? And now we can track that particular IP. Network management needing independent unique source IPs for SNMP responses is also supported, right? Based on this particular feature, we can use that in a different way as per the requirement. Finally, having the security enhanced for SNMP version 3 user configuration, we have SHA 256 and AES 256 support in place now. Such network management also needs, right, to have a secured secured with latest authentication and encryption algorithms, which helps in secured SNMP communications. It's all related. One of the use cases of SNMP usage would be having SNMP version 3 latest authentication protocols in place. And if our managed devices are not supporting that, then your authentication may not be, and the encryption may not be high enough to communicate with the server. So we, with this release, are providing this, and we are able to get the communication more secure between server and the managed devices. Right? Okay, so that's about the use cases. Let's get into details. Now, details will go one by one with respect to what we have in place. Now, you see, providing layer 3 addressing and physical entries, MIB, that's what does the name suggest? We are talking about providing IP, let's say IP interface, table entries. To some extent, we are talking about our table entries, right? With these object identifiers, we can um, get those details. So these object identifiers help provide granular layer 3 IP addressing details and network to physical entries, right? It is often required to gather an SNMP walk from a customer's device to troubleshoot an issue for missing or inaccurate statistics, especially for networking devices or any devices powered via SNMP. Very much natural to have that requirement, and especially while troubleshooting, it helps a lot having these information retrieved through SNMP. This particular MIB will provide support for the ROP entries, SVI entries, lag interfaces, even the loopback interfaces, right? It gives out all those details when you use these MIBs. SNMP version 1, 2, and 3 are all supported. Use them. The MIB file for this object is IP-MIB, and under that you have these OIDs, which are the parent OIDs, IP address table, IP net to physical table, and their specific OIDs here. You can use them to get those details. We have, I have in my next slide, you will find how this is the parent MIB and how what all are connected, what all are present for the child MIBs there. Okay. You see on the screen, it's a little filled up, but it's very important to understand that we, on the left side of the screen, you will find the objects, the old OIDs and the status of those OIDs. These are all for your understanding that how we have new recommended object and new OIDs which are in place and which are current, right, compared to the older ones. These are the main IP map folder, and that these IP address DDR are the OIDs. I don't want to read through them, but this is for your reference. These are their own new OIDs and description on explaining what it does, right? IP address prefix length. When you use these OID, it will show the prefix length associated with this prefix. The value 0 has no special meaning for this object. It simply refers to address ::/0, right? Origin, with this object identifier, you can use that to get the origin of the address, what type of address type it is, whether it is broadcast. Now, broadcast is not a valid value for IPv6 address as per the RFC 3513, but this particular OID will give you the type of address, status of the address, physical. This would give you mainly the ARP table address, physical table, the IP address translation table used for mapping from IP addresses to physical addresses, and it's indexing, right? IP net to physical PH wireless address. This will be media dependent physical address, physical type. So basically, if you look at the type here, it shows as whether it is static learned or dynamic learned or local learned. So you can use that, right? So all these are there, and you see dot 34 is mainly revolving around IP addressing layer 3 interfaces. Dot 35 is revolving around physical IP net to physical address. So that's another way at remembering the OIDs. Okay, getting further into the same MIB, I have divided this slide as MIB name parent, IP address table 34.34 as you see, and these are the child MIB of this particular MIB, right? 34.1.1 would give you IP address type, 34.1.2 IP address, 34.1.3 IP address index, and then the prefix and IP address origin, right? I can go on and list here and the description as well. So let's say if you're talking about IP address type, the type of address, if it is 3, it's broadcast and it's not a valid value. If it is 1, it's a unique, not an IP valid value for IPv6, I meant for broadcast, right, in this particular output. If it is 1, it shows that it is a unique IP address type, right? So these are the ways to look at it, and I've divided the slide with the description. Now AOS-CX support is read-only on all of these OIDs. I also highlighted how AOSS supports and what are is the max accessible value there, and what is the max accessible type as per RFC of each of these MIB. Okay. All right, let's get into the net to physical address. Same MIB with talking about our table entries. You will find the parent MIB as IP net to physical table here, and that's .35, and the child MIB is 35.1.1, 35.1.4, and so on. With the name as well, you can retrieve those OIDs and its description, right? Whether it is static, dynamic, or local, and so on, right? And how AOS-CX support is on these MIB today. It's all read only. These are not accessible, which are as per RFC as well. How AOSS support is for these MIBs. Okay. Getting into second enhancement, we are talking about view firmware images stored in flash, a standard SNMP feature where we can use SNMP walk to view image stored in primary and secondary storage of the switch. Yes, and why we need that, we talked about that in the use cases as well. Very important to know what we have in our flash memory. The MIB file for this object is under this folder, and the OID, specific OID for that is this. You can have both all the three version 1, 2, and 3 supported with this particular feature. Before 10.13, we did not have the ability to view firmware stored in flash via SNMP. We could only view the version of the active image via SNMP. Right? What's there, what's running, and what is active on a particular device before 10.13. From 10.13, we can now view firmware stored in flash via SNMP, and we can validate the firmware which is loaded before even we decide to reboot the switch, and one of the use cases of this particular feature to be there. SNMP LED locator MIB, this is also very important as we discussed in the use cases. As you see on the screen, UID, all the switch models, almost all the switch models will have this UID locator indicator. I'm taking an example of Aruba 832532C and JL626A and 627A. You'll see that the UID LED, which blinks blue, is what this MIB is revolving around. It's a standard SNMP feature to configure the LED locator, right? And requirement for this particular MIB would be the MIB of the LED locator itself and physical hardware, meaning OBS would not support this. MIB file for the object is under Aruba wired LED locator MIB folder, and the specific OID for that is this. It should be available to any SNMP server manager tool supporting SNMP read-write capabilities. We can use this to set the lights. Now, all the three versions of SNMP supported to configure or use this. LED options which we can set are as below on the screen: fast blink, flashing, half bright, off, on, These are all the ones which we can use to set, and it will blink according to those SNMP set values. Fast blink or just blink, or it will reduce the intensity to half, switch off the light, which is the default state, and switch on the light, LED. Use this to get that done through SNMP set. Okay, further getting into the VSF improvement, as I said, this improvement in VSF MIB itself is to add a new object, namely physical index, which maps the physical index of VSF member corresponding to the entity table. Right? I've shown in my next slide the difference of two, and this VSF MIB is nothing but VSF version 2 MIB. Right? That's very important. In the folder of the new SNMP, this is where you will find the VSF version 2 MIB. Is where you will find the object. To bring the correlation between the entity MIB module and particularly the entity physical table and respective VSF MIB, we have brought an enhancement where we have added an extra object, namely entity physical index, which will return the physical index of our members corresponding to the member management. What it means, right? This is what it means. You'll see before 10.13, right, we had, let's say, we have two MIBs, entity MIB, VSF index MIB or VSF MIB, right? In entity MIB, you have two, let's say you're running two VSF members and you walk, let's do an SNMP walk to that with this OID. You will see the two, it shows that it is stacked, right? And then it will show 101001, 201001, saying that this is member 1 and this is member 2, right? That's the entity MIB is what it reads the VSF members and the chassis itself. VSF index is supposed to be linking that, right, members with this OID. So before 10.13, what was happening? The VSF member indexing was just showing .1 and .2. Member 1 and member 2. It was not showing 101001 and 201001, which is supposed to be the case so that it can link or coordinate with the entity MIB, right? So that was causing monitoring tool graphical view issue kind of thing, right? Where you read the chassis, you read the VSF through the SNMP monitoring. It will show that in the graph, but the links to the members were not seen because the indexing was not exactly how it's supposed to be, right? This could be one of the use cases. It could be showing you the entirety of the VSF as one system and one link. Now from 10.13 onwards, we have the entity MIB, which is what you see here, which is nothing but the one which you saw earlier, and VSF index MIB, which is under VSF version 2 folder of the new 10.13 MIB file. You will see that integer as 101001 and 201001, right? So here the integer was 12, right? And here the integer is 101001 and 201001, which is in line with the entity MIB. Okay. I will correct this. These 1 and 2 is supposed to be red color, which I meant to be, right? This integer value. Index 1 is supposed to be 101001 and 2010. And now with this, you will be able to have possibly monitoring to a complete graphical view as well. Now, with respect to providing layer 3 routes, MIB, we can call these OIDs for getting manually configured and dynamically learn L3 route details such as route destination, index, next hop, route type, etc. from the device. MIB file for the object is IP forward MIB based on RFC 4292, which is a standard MIB for fetching the routing entry from the routing table. All the three versions are supported to use this MIB. It provides both IPv4 and IPv6 addresses from routing table entries, displays all the routes present in the database irrespective of VRF, support for routed ports, entries, VLANs, SPI, lag, and loopback interfaces. It supports SNMP read only, right? You can read those routing table entries. So what are those OIDs providing details of layer 3 routes on the routing table? This is the parent OID, and these are the you may call the child OIDs, and these are the new ones. 24.7.1.2, 1.7, 1.6, and so on. And the description is, as you see on the same route destination value, route indexing, next hop value, route type, etc. And these were the old object identifiers which are deprecated. Instead of that, the recommended object from 10.13 would be this, as I've marked here. And now you can read the routing table entries. Further getting into another enhancements, talking about the response source being an IPv6 interface. This feature is to configure a user-defined IP in the SNMP response message. Each SNMP server can independently have its unique response source IP address with this feature, and that is the source IP address now can be IPv6. We already had IPv4 and interface earlier in this response source. Now we have added IPv6 interface as well. This feature is not recommended to be used if the interface which is configured as a response source is down or not active, or if SNMP server itself is not running. Right? All the three versions are supported. Finally, with respect to the security enhancements of SNMP, right? Users can now perform SNMP work with the latest secured authentication and encryption algorithms. SNMP should be enabled in at least one VRF. SNMP version 3 users should be configured with required auth and PRE protocols, right? SNMP version 3 is supporting AES-128 by default today. Now with this new enhancement, the users are given options to plan for AES-128, AES-192, and AES-256 support. New versions of SHA that would be supported are SHA 224, SHA 256, SHA 384, and SHA 512, right? Okay, so before 10.13, you would see how we had only MD5 and SHA, right? As you see, if you configure SNMP version 3 username being v3 user1, and the authentication, and you hit question mark, you will find these two. And you had the privacy protocol, AES and DES, the only one which are present today before 10.13. Now from 10.13 onwards, you will find as many as you see on the screen, authentication protocol and the privacy protocol, which we just discussed. Okay, further getting into platform-wide support of these new enhancements, as you see on the screen, almost all of them are supporting all few where hardware require, let's say few firmware view is not present on OVA, LED locator MIB is not present on OVA, VSF member indexing is not present on OVA, as well as many other platforms except 6200 and 6300. So this is what we can take from this slide. All right, getting into configuration, we can have step-by-step process as well to understand the configuration. Basically, I've taken an example of SolarWind, which is our SNMP server or manager. As we say, we are trying to add our agent, which is the switch, right? We can click on settings here and get into manage nodes option and click on add node. Add node is nothing but to add the switch or the agent, right? Click on that, you will find this screen where you can use the IP address or the following host name. Here I'm using 10686. This would be the same IP for my demo as well, which is nothing but the management IP of my switch. And this is the switch IP address. I just add that here. Use what type of version I need, what based on whatever my requirement is, whether SNMP version 2C or SNMP version 3, have a relevant community string configured, which should be the same on the switch side as well, right? It's very basic and we have been using that for years now. Once we add that, we can also leverage, for example, to have a walk of particular OID or MIB file, we can have an MIB built-in MIB browser of SolarWind itself, the node management option. And if you type in OID for layer 3 addressing detail, which is nothing but IP address table, which is the parent MIB, it will list out all the child MIBs and OIDs, etc., everything over here. And you can just, when you, so it's running, basically it's running this on for your agent. It's doing a walk from the server to the switch, right? It's taking out information from the switch real time. And you'll see, for example, I've just clicked that for our convenience sake here, the IP address type. It shows 1 for all the entries, and 1 is nothing but unicast, as we saw that in the details section, and saying that this is the type of IP address you have on this particular switch, which is a unicast IP address. Similarly, you can click each one of the file, maybe the OID, and understand what it's talking. So this is just to show what I am using in my configuration. I have used the management IP 10686 as you see, and these are the IP interfaces which I have available on the switch. This will be useful in for our upcoming slides as well, right? And this SNMP configuration on the switch itself, uh, I've varied my configuration across different VRFs with different community strings, right? So I'm using them and I'm also showing you why I've configured so many. So basically I've used that on VRF1 manually configured SNMP, VRF settings, then default by default, MGMT is also done, and because that's where my SNMP server is coordinating with the switch through MGMT link, and that's why SNMP VRF MGMT needs to be configured as well to have that connection. Okay. Viewing switch layer 3 routes using SNMP walk, right? You can, I'm just trying to show how you can do a walk through CLI from an Ubuntu server, right? You just use this command to saying that SNMP walk, we are using version 2 community, -6 community, which is public. Give out an IP address of the switch or just type in localhost, and then you will have the OID for retrieving viewing layer 3 routes of that particular switch, and just -m all, and you will see all the route entries present in your routing table of that switch, right? And it's showing all both IPv4 and IPv6, as you see, 1080.20.24/24, or the next hop 192.168.1. So you can just use this. It's just showing you the entries, right? So route type, then route protocol, then route age, route next hop areas, metric, route status. All these are the child MIB of this particular main layer 3 route. So it's showing you all the route entries. So you can also do this as well. Further getting into the firmware viewing from the flash, we can utilize SNMP walk for that. I've tried to highlight what would be the OID and how you can call it. I've used version 2 community with the community name as public. Can give out the IP address of the local host and give out this particular OID. You'll see that talks about string, primary, and secondary with the firmware images, the dates, etc. You can cross verify that with the show images command, which is the active image as primary here, right? And that's how you would see the viewing of the firmware from the flash. Further getting into SNMP LED locator MIB, you can have, let's say, uh, configure that. To achieve this, you need to have SNMP server community. I've used user one as the community. I've given it an access level of read write so that we can set the LED. So access level is read write, community user one, show SNMP community, you will see user one, read write access, and then you'll see under VRF management, I've configured it, right? Right now, when on the Ubuntu server, if you, or the SNMP server, which is what I'm using this for, SNMP, if you do SNMP walk, having the same community user one, local host, and then you give out this particular OID to set. Right now you're doing walk, so you will see what are those child map of it, right now by default is off, so it's showing the string is off. If you want to change that, if you want to switch on the LED locator of the switch, you can just do an SNMP set using this and say on, right, the codes, and the string will become on. That means right now the switch, whichever switch you are doing this set to, as this UID blue indicator on using this, right? So now it is supported from 10.13 onwards to do this. SNMP response source IPv6 interface, you can just see as you see on the screen. We do an SNMP server, response source, and question mark. Today we are seeing three options. Before 10.13, IPv6 was not there, it's just IPv4 and interface information. Now you can use IPv6 address, right? You cannot put /64 here, it says no matched command. You just have to put the entry without this /64 and VRF default, and that is it. Now it will, for all the response source would be through this IP. Now finally, with the support for SHA 256 and AES 256, you will see under SNMP version 3 user, and the username I've used is version 3 user 1. Authentication, you'll find all these options now in 10.13 onwards. Authentication password, with whether it is cipher or plain, you can use, and then you can give the privilege as any of these, as in not the privilege, it's the privacy protocol, any of these, and then give the privacy passcode in plain text, and that is it. And so this is the entirety of it, to have a secured communication between the server and the switch. SNMP communication. So you have this configured. The same has to be configured on the other side, that is on the server side. So I'm using this SolarWinds server and configuring. As you remember, I was doing node management. Under the node management, I have SNMP version 3, and you can use the username here and then select the authentication version 3 method, and then you can also select the privacy method, encryption method. Getting into best practices, we can have a look at response source IPv6 interface configuration. So it's recommended to use the loopback interface or IP address of the loopback interface as the response source. simply because it does not go down, right? If a device does not support a loopback interface, then configure SVI interface or SVI IP address as the response source. The active gateway IP address cannot be configured as the response source. It is recommended to limit the maximum number of response sources to 5, right? The interface used for the response source should be in the up state. If the interface is down, the default source IP will be used. The use of UDP6 is mandatory, as you see in the syntax below, for IPv6 SNMP operations. SNMP walk, uh, hyphen v2c community public minus m all UDP6 colon and then the syntax of the IPv6 SNMP operation. That's the mandatory format. For the SNMP version 3.256 SHA and AES, SNMP should be enabled in at least one VRF. The SNMP version 3 user should be configured with required authentication protocols, right? Of course. Getting into troubleshooting, ensure that there is reachability between the SNMP server and managed devices. Yes, that's the very basic thing, and we usually tend to assume that it's reachable, but it's always better to have that checked. Ensure SNMP credentials, community strings are correctly configured, both in the SNMP server and agents, right? SNMP ports 161 and 162 are open and not blocked by any intermediary to firewall, if any, between the server and managed devices. Ensure the authentication and encryption mechanism is constant when using version 3 communication. Ensure browsers have appropriate MIBs present. Very important, right? That browsers should be having those updated MIBs which we have for them to do any kind of operation. To ensure MIB OIDs are correctly retrieving outputs, we can also we can do walk on the managed device prompt itself and see the outputs and compare that with browser outputs and see how it retrieves. Right? That is also another way of cross-check or checking the outputs. Further getting into troubleshooting for the layer 3 addressing details, you can just do a walk from this SNMP server here with the IP address table, and you'll see that the 1080.255 it's showing the right thing, and you can cross check with the show IP interface brave. VLAN 90 is what this 1080.250 is, right? And 192.168.8.1, which is under VRF 1 actually. The previous one was the default VRF, and you will see that entry here as well, 192.168.1. Similarly, check version 6 interface, and you will find that here, right? Network to physical table, which is nothing but the entries of the op table. If you're using in GUI, for example, in the previous one I used CLI, Ubuntu. Now I'm showing the SolarWinds. You can run or do a walk here with this OID as you see on the screen. And when you see the IP net to physical address, you'll see the MAC addresses of those, and cross check with the show our MAC addresses here, right? There's another way to look at. You have certain different MIB browsers also available, which you can use to see the entire tree of the MIB folder, which talks about parent MIB, child MIBs, etc. And you can click on that, have the address of the agent, configure the switch here, have the OID, whichever you want to run. If you want to do a walk, you can use the walk here. I'll show you that in my demo. Click on go, you will find those. It will do an SNMP walk of that OID to that switch and give out those IP. Here I'm using physical IP net to physical address, and shows now using this OID you're getting those MAC address, right? So you can use this as well to troubleshoot, to read. Similarly, for layer 3 routes, from the routing table, you can SNMP walk and you'll see all those components of the parent's name of the particular parent name of the child, names of the parent name, and then you will see those entries of the routing table with the next hop and other details. That is, you cross-check with the show IP route and show IPv6 route VRF, and you'll see 192.161.1, 115.2, and here the IPv6 entries. Further getting into the demo section, let's talk about a topology which is very simple and straightforward so that we all understand the the new enhancements which I'm trying to show. So I have a VSF switch, which is 6300 CX switch connecting to our SolarWinds server, and we also have interface management here. I'm using the management interface of the VSF switch with the IP address so and so. So the SNMP is on VRF and GMT, right? Okay, let's get into the server. Now, I'm just trying to show here how we have management interface on the 6300 VSF. Let me get into the SolarWinds, which I have here. I'm trying to highlight again. Okay, all right. Okay, so getting into Orion version of SolarWinds, this is how the page looks like, the summary page. I have added a couple of devices already, which is 6300 VSF, as you saw on the screen, right, on the demo feature PPT. Its IP address is 10686, and you can see the status of the nodes. How do we get there? You can just click on settings, manage nodes, and you will see all the nodes which are being managed here and their health. I have already added this, so just going to show you how we can just click on add node, give out the IP address of the switch, right? And I've already added that, so I'm not going to add that here, 10686. And then you can select what type of community are you using, whether it's version 2 or version 3. The port number is by default. You use the exact community string you have configured on the switch, right? Whether you have read-write community string available, mention that. And if you use SNMP version 3, you will further see the username context and the SNMP authentication method and encryption method. So if you choose the new one, which we have um, SHA, you will find that you can select this options which you have configured on the switch side as well, and you can just quickly select the same here, set the credentials, and click on next. Once you click on next, it would take you certain states like choose resources here, add pollers if required, if you want to change properties. Rest of all would be same. So we'll just click on end. You would find the node getting added here, and the reachability is also there where you just use a ping response from the switch as well, just to be sure. So that's about adding the node. Let me try. Okay, manage nodes, right? Now, once you get into this, once you have the node up and it talks about that, click on that and you can see various options of this particular node. What is the polling IP address, description, system name, all are being read. You will also find the alerts here. This object can trigger availability statistics, health summary, polling details, and you'll find CPU, by percent loads, and current hardware, all IP addresses on 6300 VSF, this switch, right? all the interfaces, current percentage, utilization of each interface, right, etc. I'll just quickly scroll down, right? We are now going to concentrate on there's something called as MIP browser within this, and you can click on that and probably have all the available OIDs. You can select that, or you can just add the MIP you would want to. Let's say I want to use a very uh, parent MIP, which will have multiple child MIPs, which we talk about, right? L3 addressing and physical entries. So I'm going to use L3 addressing as a demo, and you can just paste that here and click on select. So it's going to take a little time because it's a huge um, uh, folder. It has multiple child maps about IP addressing, others, right? You can use that. Also, there is alternate ways I'm going to highlight. While it's taking time, let me try and show you. There is something called as MIP browser, which is uh, specifically just targeted as MIP browser, right? You can use this MIP browser also to find the tree. Let's say I have certain, let me unload the MIP which I already have so that I can start from the beginning for you to understand what I'm trying to show. I just clear the table here. Okay, let me see if it has come up in the background or it's taking time. So in the meanwhile, I've added the same IP address which you just saw. If you click on advanced, you can put the port numbers, read community, write community, which you've configured. You see user one is the read write community which I've used, and SNMP version 2 from the switch in the details and configuration sections, right? And okay, in the background, let me go back and show you that we have IP address table, and you can extract them here and extract them here and click on IP address entry, and once you extract them, you can use, let's say I'm going to use um, type, right? You will see that the type of those IP addresses on this particular switch, you see 6300 VSF switch here, is 1, and we discussed that 1 represents unicast. There's a description for it, right? And you will find that 1 is unicast. I've highlighted that in the detail section. So these are all the child MIPS of that. Many of them are the description, and the access level is also described in the detail section. And you can do an easy walk from let's say the MIP browser here. You can also do that from an Ubuntu server, and it's a read only. So yeah. Next, about, let's say I would want to talk about the MIP from the LED locator, right? So this is the LED locator OID, which I have highlighted. And either you can directly add that here, right? Just paste that here and use the walk operation, for example, right? Or you can load, let's say if you want to load, let me first show you this just to keep things simple. This is the OID for the LED locator. I'm going to walk it, and you will find that there are the sub-child OIDs here, right? There are so many which has come up. If you scroll up, you will find that you have the string value off. So this is nothing but telling you that the LED is the status, and you have other details about it. Now you can also do a set, right? Remember, if you want to set, let's say, the same, and you say value is on. We talked about this in the details and the config section, in the presentation mode. Set succeeded. Now the LEDs would be, the LED of this particular switch would be having an on status. A blue LED would be on, right? So you can do all that with respect to this MIB, and let's say for the VSF, I would want to show you what I had showed in the detail section of the presentation. There are two, right? Entity MIB and VSF version 2 index MIB. So if you want to see the entity, the main MIB of the VSF chassis, let's say I'll copy this and I'll clear this table for clarity, and I'll paste that. I'm going to do a walk, right? Let me, yeah, it's done that. So this is the entity MIB which I've run, and you'll see if I scroll up, it has come at the end of the MIB now. Let me see. Yeah. This is what I was talking about in my presentation as well, right? So 101001 talks about how this is member one, and if you scroll down, and its own details of those, and then you have um, scroll down. Yeah, there it is. Okay, 201001, and it starts with here for the member two, right? So we have this in the entity table. Now, if you want to index that for the VSF member, right? We have a VSF index. Maybe if I copy paste, clear this table, since this particular switch is running 1013, you will now find the values correctly displayed here, right? This is what I was talking, 1001 for index 1, 101001 for index 2, member 1 and member 2. This value is updated, and this is the VSF improvement we have come up with, right? So this is for the VSF. Now getting into, let's say, layer 3 routes, right? And this is the main MIP for that. If I use or run layer 3 route on this, let's say I clear this table and I'll paste that and do a walk, you will find all the routing table entries, the IP addresses, details here, right? It's still loading. So once it loads, it should come down at the end of the map. It's a huge table, and yep, there it is, SNMP end of the map view. You will find various ways of you'll see those IP addresses and the value, the type, the name of the object identifier, etc. So now getting into how we can load the MIBs, you can just have click on file, load MIBs, and this is a folder which you may just have downloaded from the ASP portal, the SNMP newer MIB, right? Having that here, you list all the MIB folders which we have. You can select all of them, or you can select the one which you need. Let's say I want to use LED locator MIB here. Just click on that and it will open up. And this is the MIB tree, that is the main parent tree, where you can select which one is the one which you need, right? And you can run that here. It has selected this, and maybe you can just run that and it will show you all the MIBs and the entries of that particular MIB, right? So that way you will also have, let's say I want to clear this just to be sure, and now let me select this and click on OK. There it is, right? On, right? We had selected, we had changed the string, or we changed the LED of this particular switch to on, remember? And if you see that, it's on here. We have set it, and now we can walk and see that. So that's where you can have an MIB tree here as well in the browser. See which one, which parent, among which parent MIB you will have child MIBs, and select exactly the one which you need and run that. Yeah. That's about it on this particular demo. I would play the one with the response IPv6 interface response source, and there's a different a slightly different IP address and setup there. So I'll explain that as well. Further getting into the demo, I would be covering an IPv6 interface as response source. We discussed what it is in detail in the previous slides. Let me quickly get into the demo. I have a server connecting to an interface 1110 of 6300 switch, having an IPv6 address as this on the screen. Server has the IP address of 100:4. I also have a loopback one interface configured as 2001:2 on the switch. What I'm trying to show is that how response source, the request is communicated on these two IP addresses, and the responses is also from 102 before using this feature. But once we use the feature, we configure interface IP loopback IP address as 2001 as the response source. All the responses would be from the switch would be on that interface instead of 100:2. So let's get into that. So I have a server. I'm trying to extract the MIB4 file on the server so that it has all the MIBs. The steps would be as you see on the screen, wherein I'm trying to um, create a directory, right? .snmp. Getting into that, we would create another directory MIBs. Yeah. Okay, so let's now copy this tar file into, let me copy this correctly, paste it into the folder SNMP MIPS. That's complete. And let's see if we have that. Yes, we do. Now let's try and extract the tar file, seeing all the MIPS in that. Yeah. Yes, we have various maps. Let's have all copy all those maps from that folder, right? Everything into a particular the folder which I have. I would want to connect place that into, right? And the one which I created. So it's there right now after extract, and I've copied that on the main folder. Let's quickly, now we do have the maps in place. Now this maybe is just to show you how we can extract that on a server. Also, I would want to use a sample OID, right? So for our demo, we would have an IPv6 address configured as I showed on the presentation. 100:4 is the IP address of the server, Ethernet 1 interface. And if you see, that's the one right there. Getting into the switch, I am trying to give an IP address to the interface 1110 with the 100:2, and that is there. Let's see the connectivity between both of them, if it is reachable, the server and the switch. This is the agent here, and it is successful. Okay, now since we have established the connection, let's keep our SNMP configuration tag. So I'm going to create a configuration IP on the default server just to show you there. And I would want to have the SNMP walk in place. I will run another screen where the TCP dump is enabled on the server, right? And I will keep the SNMP walk command ready. As soon as I hit enter, I should see the 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 communication between the switch and the server. So this is the SNMP walk I'm using with version 2 public community and the IPv6 address which we created. We'll just take out one of the random OIDs from the extracted file which we just did from the MIBs above, right? Because it can be anything. I just want to show how the responses goes away. So I have this. I did not hit enter. I know I in my other tab I have TCP dump running, so I'll quickly do that. Keep that ready, and then swap the screen and hit enter here. Yes. As soon as hit enter on the other screen on the TCP dump, I'm seeing. Let me scroll up. I'm seeing. Um, you see this from the get response or get request from 104 to 102, and the response is from 102 to 104. You see on my cursor here, right? That's what is happening right now, right? The get next request is from 4 to 2, response is from 2 to 4, that is from switch to server 102. Now let me create a loopback address, okay, with an IPv6 2001 and oh, okay, I should have added address there. So IPv6 address and 2001 colon colon 2, and I see I have created a loopback of a different, and I'm going to change the response source to this particular IP, right? So all the responses now would be from this IP instead of 100 colon colon 2, and that is what we are trying, that is what the feature is. So let me walk again on the same command and see now on the TCP dump. If I scroll up, you see the get request is all from 104 to 102, but the responses now is from 2001 colon colon 2 to 104. So responses have got changed. Switch is using loopback 1, and that's what I had response source configured here. Okay, that's about the demo of this particular feature. Yes, we are at the end of the session. Thank you everyone for joining in.